Hey, welcome back to the shrine for the hand-me-downs of the industry. You know the place? It's a good place. I started on this new project making a sphere for the fixture. If you haven't seen the previous video, check it out. Making a tool post to turn a ball or a sphere. So in this case I already chucked in a 2-inch 6061 aluminum and I turned it down. I kind of straightened the end, doesn't matter, it will be machined. And what I did is I measured the thickness of this cut-off blade. This is 3.05 millimeters. Okay, so what I'm gonna do is match this edge to this surface here. That's gonna be my 0 point. I created a cheat sheet. So this sphere here is 0.5 millimeter larger radius. I'm shooting for 21.8. This is 22.3. And this, you can imagine these steps here. Each step is the thickness of the cut-off blade. So what I'm gonna do is come in with a cut-off blade and kind of rough in the shape of the sphere. And then this one shows the depth of cut relative to this line here, okay, this tangent line. So that's what I'm gonna start on right now. So the roughing is done. As you can see, half the sphere is starting to take shape. I'm gonna go ahead and replace the tool post. I forgot to mention that I made a tool holder. So I put this triangular cutter on it. It's held by a screw, a single screw. It's got a shoulder here. So this is resting against the shoulder. It's like right halfway. It's probably not the most ideal solution in this case, but this is what I have now, and it's mounted on the boring head, and the boring head is mounted on the tool post. So now I can go and move it back and forth just as you see it. So that's gonna create the sphere. Okay, here's a cylinder head. It's got the combustion chamber, spherical combustion chamber, and has a good match. I'm not sure exactly how much imprint it has. I'm gonna paint it up with some kind of paint and see how much transfers. This is the current boring head I have. I removed it from the stem, and the problem is that the adjustment screw is on the bottom side and the tool bit is being mounted here. So when the tool bit is up, I need to reach from underneath with the wrench for adjustment. So what I'm doing here is, you can see there are two slots right there. Okay, they engage the screw. This is the screw, and those slots engage the screw. So when the screw is moving up and down, the head is moving with the screw, and you can see the fine threads on the screw, and that's what allows that precise movement of the head. So what I'm gonna do is I'm gonna cut two of these notches on the upper section so that I can reverse it. So this way the screw, the adjustment screw, is going to be on the top where this tool bit is at. There's a chance that the wall is going to break through into this hole. I did not model it up, I didn't make a cross section, but there's a chance. I'm okay to take that chance. So what I'm going to do is create a slot here. These were the original grooves, and you can see there's that marking that shows the 0 position, and then these are the new grooves that I cut, and you can see that the cutter right in the center broke through, so that this hole right here is connected to that, but it's not gonna affect the taste or the feeling. So the cutter I had a different diameter than this one, but I did the calculations in a way to make it work, and you can see that this nut, or sorry, this bolt fits nicely, doesn't have much axial play. So what I'm gonna try to do is put it together, see if it fits, and so far so good. So you can see that it goes in neatly, and this head is actually following with the bolt. As far as the cutter goes, what I did is I took a piece of 1/2 inch rod, machined it down to 12 millimeters on this side here, and basically just made a flat, and then I added a trilobular cutter to it. So this plane here, the center plane of the cutter, is right at the edge, so I can assemble it like so, and I know that it's gonna be in plane. I cut off the old piece and turned down a new piece. It's about 1 millimeter larger than the final diameter of the sphere. So what I'm going to do now is swap out the cut-off tool and just basically go in and chip away part of the of the material so it's closer resembling a sphere. So I put some daikon on the ball. It's 4175. I'm shooting for 4160, but I wanted to double check. Here's the cylinder head. I'm gonna put the cylinder head on, move it around, and see how much transfers. And you can see that right there, some transfer, but it's not really a large surface, so especially this bottom surface is not being touched, so I'm gonna keep cutting it. So as you can see, it's removing just a razor thin shaving. So the size now measures at 4366. I'm gonna put more daikon on it. Basically repeat the process. Okay, look at that. See, that was only 50 microns I removed on the last one, and you can see that the entire surface got painted, which means that the diameter of the sphere has a good agreement with the diameter of the combustion chamber. There you have it. I would say that's a perfect match. Tool did a real good job. And here you can see that it's got a really good agreement. There's a nice spot all around the spherical surface, so on both sides that sphere was touching And then here you can see that it basically touched all these surfaces here. I got the sphere completed basically, but I only need a portion of it. So what I'm gonna do is I already lined up the right side of the tool with the bottom of the sphere, and I zeroed out my readout. The next thing, I'm gonna move it in at a certain distance, and then I'm gonna start undercutting, and then I bring in the head, the cylinder head, put it on, and then see how far this surface from the cylinder head surface is. I'm going to be drilling a hole and then using a 3/8 reamer ream the hole. There's the piece. About 20-25 hours of work in it, building the fixture, turning it, screwing it up, making a new one. There you go. Let's see if it fits. When I assembled this piece into the cylinder head, this surface was a little proud of the cylinder head surface, so I need to machine it back to the left. And I made a fixture here from a scrap piece. I turned it to size and basically tapped a 1/4 inch hole and then bolted it on. So this way I can machine and then put it in a cylinder head and double check. And what I did here is I put an indicator on, and you're looking at the run out, so you can see it's around 15 microns, which is about half a thou on that surface. Rocking, you can see that it's rocking, so those surfaces do not match. I'm gonna take a 1/10 of a millimeter off and then double check it. I took another 1/10 of a millimeter off, and now you can see it's not rocking anymore. I'd say that's a good fit. There you have it. So much work for such a small part. So here's what I've done so far. I found a scrap plate and cut all the sides to make them perpendicular, and then cut two grooves here, 2 steps, so I can place it and vise like so. And then I fly cut the surface, and then I found the geometric center just manually, and then drilled and bored a hole to size. So the size of the hole is to accept this hemisphere that I created, Unfortunately, the last boring operation, something happened with the boring head, or maybe it's just me, but it's about 100 microns larger, so 4th thou larger. The hole is 4th thou larger than the shaft. So this guy fits nicely. Okay, so now I can add the cylinder head, and because I know that's my 0 point. Okay, I got it at 0. This moves a little bit back and forth. I'll shim it out. So I made these little clamps. So now I'm gonna drill and tap holes for the clamps so I can lock this down. Okay, and then I'm gonna indicate this surface here to make sure that it's parallel with the y-axis, and then I can start and go and measure these holes, the position of these holes relative to the combustion chamber. I added a layer of aluminum tape underneath, and I also added a layer in the hole, so now when I assemble it, it does not wiggle at all. So it's time to assemble the cylinder head and do some measurements. Okay, so it doesn't wobble, it doesn't move, and I know that the 0, 0 coordinate is right at the combustion chamber. So now I need to indicate this surface and make sure it's parallel with the y-axis. So I got the head locked down with the clamps. There's 2 clamps here, one is on that side, and if you look underneath, there's solid stack here, solid stack there, and solid stack on all sides. So I only added 2 layers of aluminum foil, and that kind of did the trick. It's kind of shortcoming of my machining. So now I have my favorite Mihuhogu indicator indicating this surface here. So what I'm gonna do is move the y-axis in and out, and you can see that the needle stays pretty much steady. So we are indicating on this surface, so now I know that this surface, this back surface, is parallel with the y-axis. That was the last degree of freedom that I had to take out. The Bridgeport CMM is in action, so you can see why I created this sphere, created the fixture plate, fixtured up the cylinder head, and now I can measure the position of each of these features and holes. You can see this one I found, the needle barely moves, which means that the axis of the quill is parallel to the axis of the hole. It's actually coincident. And now I can go and just read the measurement from that for the XY coordinates. So that would be all for this video. I hope you guys enjoyed it. If you like the video, please give me a thumbs up. And if you like the channel, please subscribe. See you next time. Bye.